Okay, our topic today will be on pointers and array. Okay, so we really covered the IPT concept. Sorry. Concept is the same. But that this semester, I mean, in data structure, right, in C++, right, the dynamic array is slightly different. Because when you store the data in a place or in a memory called a heap, okay, a heap ni basically macam satu buffer memory lah, ada memory. Alright, you can dynamically put data on it. Alright, so we're going to cover both pointer and array at one go. Our learning objectives basically, we already know what basically data type, pointer and array, how to manipulate pointer and array. This is how you create a heap, dynamic array inside the heap. Alright, learn about pointer arithmetic. Basically, you traverse an array using a pointer. Cover dynamic array. But this one, the dynamic array not using malloc, yeah? You're going to use heap, right? Uses the reserved word is new. Put data inside the heap, the reserved word that is new is NEW, new, okay? And then you should be aware concept of what is shallow copy and deep copy. So shallow copy is called by value lah. Deep copy is called by reference. In a way, okay? Discover the peculiarity of classes with pointer data members and look at how dynamic array is used to process a list. Alright? So then what's a list and how to process a list using dynamic array. Okay. So this is a declaration of a pointer. So the data type, this pointer P can only point to data of type integer only. Alright, this is the name of the pointer. Now, how many ways are there to declare a pointer? Okay, we just look at a few examples. So these are basically some ways for you to declare a pointer. The placement of the asterisk is not important lah. So you can put it this way, you can put it this way, you can also put it this way. But in general, everyone uses this lah. When you work or you work in a group project later on, okay, just to help your friend, maybe it's best you do like this. Everyone has a standardized view of things, but you can also use this method. It doesn't matter. That's fine as well. Right? So in this first example, P is a pointer, Q is not. This example, okay, P is a pointer, okay, and Q is also still an integer variable. Alright? So here, P pointer, Q is integer. P pointer, Q is integer. Here, both P and Q are pointer. Alright? So what does a pointer do? What data does a pointer hold? Venorika. Pointer dia hold data apa Venorika?
Sorry, sir, can you repeat the question?
A pointer, what does it hold actually? What does a pointer hold?
It points to the address, I think.
Okay, slightly betul. So dia hold the address of a variable. A pointer tu dia hold address. Ingat tak? Dia indirectly reference a variable. Indirectly. So why is it indirect? Because they put address instead of hold the value. Understand, Siti? Okay? Siti Nur Syakita, are you okay?
Yes, sir.
Alright, good. Okay. Now, have a look at this example. Okay? This is an address of A. Alright? Now, X is 25. P is a pointer. Okay? So P here is assigned to the address of X. Address of X, yeah? Now, pointer can hold an address of X. What else can it hold? Vanessa. Besides holding the address, what else can a pointer hold? What kind of value?
Can you repeat?
Besides holding an address, alright, this one, he holds an address of X, alright? Besides this, what are the values that a pointer can hold? If Vanessa cannot answer, Rebecca will help. So you prepare for Rebecca answer. Apa benda, okay, pointer boleh pegang address of a variable. Selain address, apa lagi dia boleh pegang?
It uses the address and points to the address.
Yeah, that's what really said. What else? Fikir. Awak dah tahun 1, semester 2. Cuba fikir. If a pointer hold address and points to something, what else can it do? Who did it? Get ready? If Rebecca cannot answer, you're going to have to answer. Come on. You guys are the next generation of nations. Think critically. If boleh pegang address, okay, pegang address satu. Apa lagi yang dia boleh pegang? If it points to a variable, it also point to apa, Rebecca? Come on. If it can point to a variable, okay, if a pointer can point to a variable, correct? What else can it point to? Points to nothing lah. Guys, there's something like this. You're speaking A. Opposite of A is what? Okay, so you explore alternatives. You dah besar dah sekarang ke sekolah lagi. Alright, if something points to A, you must also think what if it points to Z. Alright, so if it points to a variable, what if it points to nothing? Betul tak? If it points to nothing, address dia apa? Dia akan kita assign dia kepada apa? If it points to nothing, what do I put here?
Nothing.
Ya, ayolah nak apa dia? What is nothing? Dah belajar dah, come on. You just have to piece things together. Apa itu nothing dalam komputer?
Garbage value.
Mana garbage value itu satu value. Garbage value is still a value.
No.
Ya, betul. N-U-L-L. Thank you, Rebecca. Very good. Null ataupun kosong lah. Boleh juga. Alright, point to nothing lah. So, bila you ada pointer, you must tell it to point somewhere. Okay, if it doesn't point to anything, tak payah letak pointer, betul tak? So, pointer, if it points to a variable, you need its address, otherwise it points to nothing, 0 or none, okay? Alright, good. Okay, so, dalam this, okay, so basically ini dia nak tengok lah apa itu konsep dereferencing operator. Itu ataupun indirect referencing lah. So, dia nak tengok value dekat dalam P ni. So, P ni shows the variable X. Can you use P to change the value of X? Can. You will star. Alright? So, star P will give you the value of 25. Yeah. Alright? Here, you will be assigned from 25, you akan letak 55 kepada 55. You bukakan. Whatever value the variable P is pointing to will be assigned to the variable to the value 55. Clear? Any questions? Okay, if no questions, I have a question for you. What happens if I change this to P? What is the final value of X now? Siti or Shafika. So, what is the value of X dekat sini? X ni apa value dia sekarang?
13?
Why 13? Why 13? I cakap betul, tak salah. I cakap salah I tanya you, kenapa 13?
It points to the integer X value, I think.
Integer X value. Okay, Rebecca, do you agree or not?
I'm sorry, sir. Can you repeat the question?
If here I change to 13, okay, sekarang ni dekat sini, kat line ni ada kata saya nak keluarkan nilai C out X. Apa nilai dia? Syafika cakap it is 15. Betul atau tidak?
Is that asterisk P equals to 55 still there?
Yes, still there.
I will guess that it's 55.
Yes, betul. The value is still 55. Syafika. Because Syafika, dekat sini, kita cakap P, whatever value to which P points to, we're going to assign the value 55. P 55 ni dah kan dah 55. Okay? Faham tak? Be careful, yeah? Alright. Alright, good. Good price for you, Syafika and Rebecca. Okay, so soalan yang saya bertanya tu ada kaitan lah dengan this side obviously. Betul tak? So start ni cakap mula-mula nilai I adalah 15. J no value. Then you have 2 pointers for P and Q. So these 2 P and Q will hold an address lah. Okay? No value there. So the address of pointer P is 1084. The address of Q is 1086. Now P is assigned to the address of I. So address of I is 1080. So you get 1080 here. Okay. So now P, when P gets the address of I, should mean that it really basically points to the variable I. So you end up with this C here. C ni and you end up with this diagram here. Any questions so far? Okay. No questions, I proceed. Now, it says, you see, this is the question that I asked Shafiqah just now. Now, the value, whatever P points to, is assigned to the value of 20. So P, that's what 0 is 0, points to here. Previously is 15, now it changes to 20. Now P becomes points to a variable I with a value 20. Any questions ke tidak? Tak ada. Now, J is 2 times, the value of J is 2 times to whatever P is pointing to. So P pointing to 20, therefore the value of J now would be 40. Okay? Now, Q is assigned to the address of I. I address is 1080. So, you can dapat this new diagram. 2 pointers P and Q points to variable I with a value 20. Okay? Any questions?
So far, can't think of one.
Okay, alright Yeah, go step by step with you. Kalau you tak faham, terus bagi tahu. I tak nak ulang the whole thing. So, I'm asking you bit by bit. Tapi kalau ulang the whole thing, that means you're not paying attention. Okay, now I'm going to explain this one. Now, whatever P is pointing to, the P is pointing to here lah, I ni. Okay? Before this I is 20 Tengok sini. P, whatever P is pointing to is going to be assigned to a new value, which is the value of Q, whatever Q is pointing to. Q tadi is pointing to I. Nampak tak? Okay? And then dia akan minus 1. So Q points to I, which holds the value 20, it will minus 1. Therefore 20 becomes 90. Okay? Semua okay? Ada question? So, yeah? Now, di kat bawah ni. Now, Q sekarang, which is a pointer. Q ni satu pointer, ya? Now, it will be assigned to the address of J. J, the value is 1, or the address is 1082. So, Q akan pegang nilai 1082. So, this diagram ni bertukar kepada this diagram dekat L. Nampak tak? Now, Q has been redirected lah, in a way. Betul tak? Tadi dia tengok I, sekarang dia tengok J pula. So, dia kira dia minat orang baru lah. Okay? Now, the value whatever P is pointing to, P tadi, the point to I, which is 19. Okay? Now, it is going to be reassigned to whatever Q is pointing to. Q is now points to J, which is has the value 40. 40 tolak 1. Then, therefore, nilai baru I adalah 39. So it will assign to the value 39. Okay, ada soalan?
No questions, okay.
No question, huh? Alright, okay. So ini yang saya tanya dekat Rebecca tadi, a pointer basically can hold what in one state it is unassigned, which is not good lah. When you have a pointer, you have to assign it somewhere. So either it points to a variable or struct or whatever, or it doesn't point to anything. So if it doesn't point to anything, this is how you see it. P equals to 0 or P equals to null. Okay? Standardized is P equals to null lah. Selalu orang guna P equals to null. Because bila kita cakap equals to 0 ni, dia kira macam number. So if you say P equals to null ni, so when programmer looks, oh I know this is a pointer that points to nothing. But both will also can. Just that this one is more widely used. Okay? Now, C++ does not automatically initialize variables. Alright? So pointer variables must be initialized. Okay, if you don't want them to point anything. So that means kalau you tak nak dia point to anything, you have to write this. Okay? So, boleh tak you ada exist satu pointer that doesn't point to anything? Boleh. Panggil dangling pointer, which is not good. Okay, not a good programming because it can be somehow later on it can people can indirectly access it. Alright, secara tak sengaja. For programming is created by a lot of people. Alright, which can allow the program to give a wrong result. And you have to troubleshoot. Alright. So you have to either say it points to something or doesn't point to anything. If it doesn't point to anything, you have to tell the compiler. Can it exist whereby it doesn't point to anything? Yes. It's called a dangling pointer. Alright? Now, we're going to create a dynamic variable. Alright? Now, dynamic variable, basically data dynamic variable ni, it's placed in a computer memory called a heap. Alright? Create a dynamic variable or dynamic array. Last semester you used malloc kan? This semester you use new for C++. And to destroy it, use delete. To destroy dynamic variables ataupun dynamic array. Guna malloc. Now, sama macam betul global variable, static array, not global variable, static array size is fixed. Dynamic array, during the execution of the program, okay, the size of the array can be determined. Alright? So when you use new ni, okay, it will be the space in the memory will be allocated during the execution of the program. So here, it basically dynamically creating an array of size 10 in the heap. Alright? So this is a dynamic variable. So, precondition untuk guna dynamic variable ni, if ada memory space, then only you will be able to create the new dynamic variable. If no space, then a null pointer is returned. Because this value will be placed in the memory during execution. So therefore, it needs a space. Right? So, bila ada space, baru dia akan allow you to create a dynamic memory. Objects created by new are said to be on a free store or what we call as a heap inside the memory. So it's a region of the memory that is set aside for dynamic variables. So how do you create a dynamic variable? So this is a contour whereby this is a dynamic variable. Okay? What P adalah satu pointer. Now P ni is going to point, okay, to a dynamic variable that is inside the computer memory. Okay? Now P ni is going to be the value to whatever P is pointing to, they're going to assign it to a value of 28. 28. Any questions? So ini you create, ini you give the value, ini you declare. Kita guna pointer, because pointer tu yang akan diguna untuk point to the location inside the heap. So heap ni adalah region dalam memory, okay, whereby you can store dynamic data. Right? So this one is a one way of creating a dynamic variable. This is another method. So here is 2 lines. So this one is 1 line. Sama lah basically. They use both lah. Alright. To assign the value, sama juga. So you can use this one, this method, or this one, another method. Okay. Outcome dia adalah solution. Any questions? Okay. So question I proceed here. Now, this is to create a dynamic array. To create integer P, P akan point pada satu tempat dalam memory itu, di mana dia akan ada 10 location, right, yang apa tu, adjacent, and adjacent memory locations, alright, or basically 10 contiguous memory locations, sama je lah, basically, right, to address, to assign, so that you can keep the value inside the array. So ini means ini akan point satu tempat dalam memory. Dalam memory tu akan ada 10 tempat isi data. Ini dia pula akan merujuk kepada the first index inside the address. First index of the array. So P tunjuk kepada memory 10 tempat kan. P tu dia akan tunjuk dekat mana dalam 10 tempat tu. Index 0. Soalan? Tak ada. Benar Rita buat question? Amir? Alright. Okay. Amir, tolong explain ni Amir. Kena ni. Kita belajar dalam C dulu. So, saya nak tengok you ingat ke tak? Explain di 3 statement ini.
Mula-mula dia assign P sama dengan 25. Lepas tu
P assign 25 tu dekat index mana?
Dekat index yang apa tu, yang first sekali.
Okay, first kali, which is kosong lah in a way. Okay, lepas tu second line ni maknanya dia pergi dekat next memory location. Which is the next, betul, next index yang kedua. Lepas tu apa jadi, Amir?
Lepas tu yang kedua tu dia assign 35.
Betul, pandai Amir. Very good. So ini you traversing an array guna pointer. So P++ tu basically dia pergi kepada next index tu lah. Alright, so this one ni index 0, index 1. Lepas tu index 1 diisi value ni. Jadi katakan ada P++ lagi, dia pergi index 2. Okay? Alright. So, ini basically one way lah. Alright, this another way you gonna do. Okay, tapi dengan yang ini basically ini, okay, you ada counter called J is less than 10, J++, P, J, you assign to the value, so. Alright. Now, the thing is, ini dia akan stay fixed at the first memory location kalau you gonna loop. Alright. Okay, so kalau traverse yang ni guna P++. Tapi kalau dekat sini ni, okay ni, pointer ni dia tak berubah. Dia just stay dekat the first memory location. Index tu akan tukar tapi dia akan still point dekat the first memory location. Alright. Okay, bila kita buat use dynamic heap, ni tempat dynamic variable tau. What you don't do, you have to destroy it. Because otherwise, if you biarkan di dalam heap tu, dia akan tukar dekat situ. Until the program terminate. Okay, so you eat up memory space. So when you create new, you must also learn to deallocate the dynamic array or the dynamic variable. Right? So deallocate a value is not in the heap, allows the memory to be reallocated. Reallocated means you can put in new data when you will use it. Right? So preposition is basically they akan return pointer variable that points to the heap or zero, points to nothing lah. Post condition here, since you dah deallocate pointer variable, we have the value nothing. So tidak buang. Okay? Oh, sorry. If the value pointer variable is equal to zero, okay, or the variable ni points to nothing lah basically, then delete ada delete has no impact. It points to nothing. Else you point to the variable, say that it is deallocated or it's unassigned. Kalau tidak buang, bila dah buang benda tu dah tak point to anything kan, it's unassigned. Okay. So now you see these two pointer points to the same variable with the value negative 77. Ini is where what happens when you have a dangling pointer lah. Okay. Ini cakap dia ikuti dynamic value, put the value 77. Lepas tu you guna function delete pointer variable integer pointer A. So bila you delete, ini data dalam heap ni, dynamic array ni, deallocated. Wow. So yang ini points to nothing. So bila points to nothing, ini dia again as dangling pointer. It can lead, okay, to serious programming error. Alright. So this is where memory leaks happen lah. So by right, you should delete both of them. It's one thing to delete and two thing to delete. Now, what does memory leak mean? Alright. It means that when you have maybe allocated a dynamic data, but you never throw it away from the heap. Okay. Or inaccessible objects are left on the heap. Maknanya benda tu dah tak boleh access, dia tinggal delete daripada pointer. So, to avoid memory leaks, every point new must have a matching delete. So, this is an example of a memory leak. This pointer it points to negative 77. And then, what is called? This pointer A pointing to a new integer. Okay. A new place inside a dynamic memory whereby you can store the value, some value. That is here. So, you view this guy here becomes inaccessible. Alright, can you see that? This patutnya bila dia point kat sini, you kena delete dia. If you tak delete dia, you just ask this to point, this one lah yang akan cause memory leak. You buang memory dia. Dia ada, tapi inaccessible. Another example is two different pointers point to different things. Then you go and say, this pointer here points to whatever pointer is pointing to. So it's inaccessible. Right? So these two things here, it becomes inaccessible because you have asked to whatever that is pointing to, you ask it to point to something else. So you tak dapat, memang tak dapat access ni because nobody is pointing towards it. And you should clear the full memory. Kalau you clear the full memory, in this case, dia hilang juga lah. Kan, dia buang semua. Right? But, if you ask this to point over here, then this one is masih habis. So you got to delete it first. Alright? Then you redirect it. Now, Now, this structure basically an array name is a constant pointer. So basically, list ni pointer ni shows the first address, okay, index inside the array. So that is why this ni holds the value 1000. Okay, it must always hold the first index. Okay, the name of the pointer is for the value of the first index. Okay, so this also means, okay, for the value of 25. These two, see, ini dua kan. Basically also is this one, satu is this one, two is here. 78. But the value of this ni akan tetap 1000. Because the pointer doesn't move. What it moves is the index. So this one, basically, second. It's done. Okay. P states fixed at the first memory location. P states fixed. Nilai dia tetap 1000. Kalau you letak kosong, betul. 25 you boleh letak list 2, 78. But nilai dia tetap 1000. So the pointer never move. Ini dia move. It moves because P points to the next array component. The pointer points to the next array component. Ini P stays fixed at the memory location. So, this is the example. Okay? Okay. So, basically, when you pass pointer to a function, well, basically, you can pass call by value or call by reference. So, this is called by reference, called by value. Call by value, you pass copy data. Now, can a pointer return a pointer? Can a function return a pointer? The answer is yes. So this, at the end of this function, they return a value of what? Ralph Ashley. At the end of this function, dia akan return apa? The value tu mesti type apa?
Boleh ulang lagi tak, sir?
At the end of this function, okay, this function will return apa? Return value of type apa?
In
apa? What is in?
type in.
Mana ada type in? Betul. Dia type in. Dia ada star dia.
Address.
Mana ada address? Okay, kasih 2 minit semua orang fikir. Okay, clear off? Okay, tak apa, it's okay, no problem. Yang lain fikir, ada 50 minit. Look at this value. What does it return? Okay, Rebecca, dia return apa?
Pointer.
Pointer. The pointer is type what?
Pointer of type int.
Integer. Okay, pointer of type integer. See? So, a function boleh return a pointer. So, pointer ni adalah type integer. Alright? Now, how do you create a two-dimensional array? Okay, using pointer. This is the first method. You declare a pointer array, okay, of size 4. Basically dalam board ni, okay, dia array kan, 1, 2, 3, 4 ni array. Dalam dia isi dia adalah pointer. 1, 2, 3, 4 pointer. Pointer ni, okay, akan point pula, alright, a location inside the heap that can store 6 numbers. So you akan dapat 6 column. 1, 2, 3, 4, 5, 6. So ini pointer ni points to a heap. So heap ni dia letak size dia adalah heap. Heap dia dalam bentuk array lah, sorry. Dalam bentuk array. Alright. So this array can store integer values of 6. So dia basically dia pecahkan dynamic array yang belajar dulu row and column kan. So ini dia cakap okay, instead of having row and column, row terpecah. Dia cakap it's going to be stored as an array. Dalam array ni dia boleh simpan pointer only. Setiap value di dalam array pointer ni akan point kepada a place inside the heap whereby it can store an array of size 6. Ini cara yang pertama. Okay. So, you kena tengok macam mana you nak declare. Okay. Then, you see, now board row, itu foto yang keempat kan, ini index foto, 1, 2, 3. Ini semua dalam ni pointer. Points kepada new. Okay. New ni basically data dalam heap. Okay. Dia akan letak array type integer. Type dia 6. So, yang ini. Any question? Okay, cara kedua is star board. Okay. So basically, secara generalnya, board ni, putting here, address of a pointer to an array of pointers. Star board, satu ni, okay, so ini adalah array of pointers. Semua ni. So it's an array address of an array pointer that points to another pointer. So basically it's a pointer that points to another pointer. Board ni pula, okay, akan allow you to create a new data in the heap. Okay, so board ni, okay, new integer. So board, new integer. Semua ni pointer. Okay, dalam 10 space. Okay, imagine yang ini apa ni? Okay, yang macam ni kan, sifat 10 punya adalah pointer. Okay, and then dia nak create column. Dia cakap okay, after I dah buat semua ni pointer, okay, then I can create column dia, pointer ni akan point kepada location inside the heap. Dia store 15 data. Ini cara kedua. Right? So cara satu ni tadi, okay, you declare a pointer. Dalam ni a pointer lah. Jadi yang ini dia adalah pointer pada pointer. Okay, dalam pointer tu dia akan tunjuk kepada pointer lain dan pointer tu pula akan tunjuk kepada data. Ini column lah basically. So ini dua cara. Alright, but this one is the easiest lah. Alright, so for shallow copy dengan deep copy ni, I'm going to straight away explain the image lah, easier for you to understand. Ini kita panggil bukan shallow copy. Okay. First, points to this set of array, a dynamic array. Alright. And then you declare another pointer. And then you say the second pointer points to whatever the first is pointing to. Ini shallow copy. Okay, shallow copy, ada dia kat sini. Kalau you delete first ni, alright, kita call delete first kan. Okay, apa jadi? You deallocate first ni. Yang saya ajar tadi yang okay, you delete ni. Okay, apa akan jadi pada shallow copy ni? What happens here? Tengok ini, saya delete first ni. Apa jadi ni? I want to follow beta lah. Haris orang. Orang Haris. Saya delete first ni. Saya deallocate. Apa jadi Haris?
Second tu nanti dia macam dangling.
Betul. Dan ini points tu nothing. Okay? So untuk mengatasi masalah ni, yang di pointer ni, kita perform deep copy. Deep copy ni dia guna follow, dia cakap instead of value second point to whatever point is going to do, I'm going to say, okay, second is going to have whatever first has, whatever first the first pointer has, the value is. Dia dapat tak? Second ni akan have its own original data juga. Ini sebagai deep copy. Alright, so if we delete first, delete lah, tak data lah. Alright, second tetap ada data ni. Shallow copy dia ada kegunaan, deep copy ada kegunaan dia sendiri. Just make sure when you katakan you guna shallow copy, okay, shallow copy, when you delete second or first, whatever, you must make sure this one also you must reassign back the pointer. If you say, okay, I'm going to delete second kan, if you delete ni, ini you gonna set pada null. We need the points to nothing. Jangan biar dia dangling. Okay. Tapi andai kata you dalam problem you cakap, okay, I tak nak guna ada masalah dangling pointer. I tak nak apa ni, perform shallow copy. Then you buat deep copy. So these two data will be different. So if you make second to make changes here, it will not affect the first. So that is required by your problem. Tapi anda kata problem ni cakap, okay tak apalah, dua pointer ni can point to the first thing. Shallow copy is enough. Then okay. Tapi bila you deallocate dia, make sure bila you dah deallocate ini kan, you dah deallocate, katakan you cakap delete first. Make sure second ni you cakap the points to nothing. Compiler must know. Not leave it dangling. That's the keyword. Understand? Alright. So ini tak ada dia punya own data. Ini ada dia punya own data. Alright. Okay, so dia pointers and classes is going to do and what is a destructor. Last week kita belajar constructor kan. Constructor tu nama dia adalah sama dengan nama kelas. Okay. So bila objek tu masuk scope kelas itu, automatically its constructor akan di-invoke. Okay. And then bila how many constructor can you have inside the class? You can have one or more. Bila you have more, the default is which constructor? The one that has no parameter lah. Alright, yang lain tu adalah overloading of constructor. Okay, what makes one constructor different with another constructor? It is dia punya parameter. Today you're going to look at destructor. Destructor hanya akan ada satu tu. So that means bila object tu exit the scope, dia akan destroy all the value. Alright. You're going to look at what is assignment operator and copy constructor. Now, okay, as I said, okay, the destructor is implicitly invoked bila class tu goes out of scope. Yang object tu class tu goes out of scope, dia akan destroy. Okay, this one. Right? Static object pula, ini static object goes out of scope when the program is terminated. Tapi you have to declare the object as static lah. Ingat tak you belajar function tu kan? You kan ada static variable kan? Static variable, okay, a function, if you declare it as a static, the value inside the function will be destroyed when you exit the scope of the function. But if you declare it static, value tu akan hilang when the program terminates. Same concept here. Okay? So the disruptor is basically to clean up stuff, right? Now here you akan ada two objects from the pointer data class. Okay? So dalam data class ni dengan x length p. X length p. Ni data dia. Objek dia dua. Satu dengan dua. So, this fellow here is a pointer. This guy here. So, P is a pointer. So, if P, alright, points to here, this guy here. So, bila you nak cakap, okay, how do you ensure that when you destroy object 1, this value is also destroyed? If you do this value here, this guy here must be reallocated. Alright? Kalau you just destroy ni, pointer tu destroy lah. Tetapi this one is still inside the heap, betul tak? Think about it. This guy points to this one, okay. But if you destroy this object kan, dia go to all scope, ini saja dia destroy. Tapi ini, kekal ada. Alright, so you have to reallocate this one as well. So, you have to have a disruptor. Nampak tak? This guy is called a disruptor. Disruptor ni, dia punya symbol, pointer, nama kelas tu adalah pointer data class. Betul? If constructor, nama dia adalah sama dengan nama kelas, disruptor adalah sama dengan nama kelas juga, tetapi dia ada hidden. Nampak tak? Okay, so dia cakap, you see, in the event this object ni keluar out of scope, ini dia destroy, okay, ni destroy, tetapi ini point pada state, ini destroy, ini masih kekal. So dalam disruptor you buat, you mesti bagi tahu dia, I have to destroy the value of P, which is this one here. So ini whatever P is pointing to, reallocate. Nampak tak ini? So bila objek ni, one ni goes out of scope, dia dimusnahkan, maka dalam disruptor itu dia cakap, this value here, ini musnah, therefore I have to musnahkan this one juga. Tetapi compiler you will not do the work for you. You have to write that code. By you write it inside you punya disruptor. Faham ke tidak? Compiler you hanya akan destroy this value saja. Ini dekat X kan. Tapi yang ini dia tak buat. Ini you yang kena buat. Buat dalam disruptor. Faham tak konsep dia? Listen, here. Listen to. Senchu, can you hear me? Okay, alright. Rebecca, okay, understand? Alright, Rebecca understand. Amir, you understand or Amir? Okay, Amir, then you repeat what I say, Amir. Why must I create this disruptor? In this particular example, okay, why must I create the disruptor, Amir?
Sorry sir, tak jelas saya cakap tadi. Boleh ulang?
Okay, kenapa saya perlu create a disruptor untuk masalah ni? Bila ini keluar out of scope kan, kenapa saya perlu create disruptor? Biarlah dia keluar out of scope. Apa guna disruptor tu?
Itu
Tak apa, it's okay kalau kita tak jawab, tapi just fikir. Anak yang lain fikir juga. Faris, kenapa Faris? Apa guna disruptor ni? Dia keluar out of scope, dia destroy, so what?
Sebab kita punya compiler tu tak automatically deallocate sekali point dynamic dynamic
Array.
array.
Yang
So kita kena
dynamic
buat
array.
manual lah.
Ya,
Kita
siapa yang
kena
point
guna
kepada?
destructor.
Okay, siapa yang point pada dynamic array tu?
Sorry?
Siapa point to the dynamic array? Siapa yang point pada dynamic array tu?
Object 1 tu, yang ada P tu.
Betul. P tu. Pointer P tu. Array tu. Okay. Bila you keluar out of scope, yang ni dia destroy. Pointer tu pun destroy lah. Dia out of scope kan. Tetapi yang ini masih dalam memory tu. Ni. Hello ya. File tak akan buat untuk you. So you have to buat tu dalam destructor. You yang buat. Faham? Alright. Kalau you tak buat, then memory you, dia akan kekal kat situ. So dia akan eat the space. Memory leak lah jadinya. Okay. Right. Very good. Right, thank you, Faris. Okay. Summit operator, slide 38, level 55. Okay. Kasih break 5 minit. You boleh pergi tandas dulu, minum air, then come back in 5. Okay. Alright. Break ya. Okay, so this is an example of how to write a structure ya. The structure nama dia sama dengan di tab ni, you can get the hidden pointer. Now, this is an assignment operator built inside the compiler. So here it means that object 1 is assigned to whatever object 1 here basically copies object members. This one copies object 1 to object 2. Alright? Now, because it's a pointer, if object 1 is a pointer, we have a pointer here. Because it is a pointer, what happens is that it will perform a member one's copy of the data. Basically, it's shallow copy lah. Data here, when you put it as same, alright, object 2 is equal to object 1, dia akan shallow copy. So like shallow copy, if this one goes out of scope, therefore, this one points to nothing. Alright, so you want it to have a deep copy, whereby if you destroy this one, P here, we still point to something, like this one here. Alright? So, to solve that, we use something called overloading assignment operator. So, you don't use the compiler punya constructor, you create your own constructor using const class name and operator equals to const class name address. Okay? So, when you implement it, it looks like this. Class name and class name scope resolution operator function equals to const class name by object. Alright? If, alright, this is not the same as the value inside the right object, then only you can see anything that is not the same as the one inside the right object, then you copy it to the first object itself. Alright? You copy right object to the new object lah, which is first object. Alright? Then you have this big copy of data. So you do this function, const class name and operator equal data to const class name. Alright? So because dia pointer tadi dia akan guna default number one initialization. So you have to override the definition of the copy constructor given by the compiler. You use your own class name, const class name and other objects. Okay? Alright. Any questions so far? So ini dipanggil is overriding copy constructor. Why you override the copy constructor? You don't use your own compiler punya copy constructor. That one is called default member-wise initialization. Alright? So you use your own with this overloading the assignment operator. Any questions? Okay, no question.
So far, cannot think of one.
Okay, alright. So, if okay, I proceed with the array-based list. Now, this the list of data structure. We are talking about a linear list. Linear list is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now, we're going to look at sequential access. Alright. Kita tak tengok ini dulu. This one out. We're going to look at normal list, general list. So, dalam general list ni, okay, a list is a collection of items of the same type. Macam array kan? Collection of items of the same type. The elements are ordered, meaning first item, second item, third item, and fourth item. Okay? And duplicate values may occur inside the list. Length of the list is the number inside the list lah. Number of items inside the list. So what are the operations that you can perform on the list? Ini satu thing. You can create a list. You can determine whether the list is empty or not. You can determine whether the list is full or not. Okay? So when you create a list, you must have this following operation. Alright? So what operation must have? Create a list. Check if this is empty. Check if the list is full. Destroy or clear the list. Insert an item inside the list. Remove an item inside the list. Alright? So this is the URL diagram of the list. So these akan ada data, type of data that you can create is keep inside the array list. What is the length of the list? Alright, and what is the size, maximum size of the list? Below here are the operations that you can perform on the list. If the list is empty, the type, return type is boolean. Maknanya, either it's empty, give the value true, or it's not empty, give the value false. That's why the return type is boolean. List size is the size of the list, so return type dia adalah satu integer value. Alright, any questions? So ini ADT ya, kita dah cover in the last class. Kalau you tak faham ADT, and this URL diagram, please review the previous lecture. So how to implement the list? Please look at your textbook, page 172 and 174. This is a list. Okay. Type of data are all in an array. Alright. This is a sequential list. So 35, 12, 27. So you have to search 27. So when you want to search 27, you check the control. The exposure. V27, no, return false. 1, same or not? Not same, return false. 27, 7. This 2, alright? So we have found the value. So do you return the value or not? Maybe you return the location. So here is a template. Okay. The way is sequential search. Ada sequential search. Yang ini. Alright, you pass the element. Okay. Sequential search, the array. And it returns the value of that integer. Okay. So return the value. Start integer. There are dua variables, location, then is the index, and then dia akan ada boolean function. Boolean function found ni, dia start dengan false. So dia boleh cari. Bila dia cari jumpa, baru dia set kepada true. Kalau tak jumpa, dia akan tetap, dia akan jadi negative 1. Okay, so never mind. I go step by step. Okay, so this one dah terangkan tadi, yang ini, here, sequential search, we can start integer. Okay, this is the name of the operation. Ini scope resolution operatornya ini pelan-pelan. Alright. Variables location and the boolean function. So dia cari dulu. At location 0, location must be less than the length of the list. Here you increase the location from the list you try to start from 0 to whatever value now. 0, 1, 2, 3, 4, 5. If the list location is the same as the item, diterima item kan, yang you nak cari tu, then you set the boolean function value from false, you set kepada true. The minute you have found the item, you break. Whenever you found something, okay, you can return the location. If you find it, you return the location. If you don't find it, you can return the value negative 1, meaning you did not find it inside the list. Alright? Okay, any questions?
So what's the template? What does the template there mean?
Oh, template is this one. Sample.
Oh, just the entire diagram.
No, not the diagram. It is from this template. HTML template. There the class template, class element part. Okay, template ni from HTML diagram. Dalam so that bila you declare class tu, you can ada get, list, rank, max size. These are all the operations that you must have inside the implementation of this your class. Sequential search is just one of them. This one. Ini semua adalah template dia. Buat implementation nanti ni, you mesti ada implementation untuk each entity. You mesti ada implementation untuk each code. List size, max list size. Is that clear?
Oh, okay.
Okay. So ini semua ni kena implemented. Dalam lecture slide ni, dia include satu saja. Okay. Adakah nama dia kena sama dengan ni? Tak lah. Depends on whatever task ni kasih lah. Ini dia kasih nama dia array list element type. Depends on whatever you give the class name lah. Okay. Tapi bila you kasih nama sequential search, you just follow this template lah sama. Okay. Hello? Hello, anyone? Yeah, alright. Apa dia ada? Dah, you can see right now. Jadi lah, not clear. Never mind, kalau not clear. Never mind, at least you get an idea how this works first. Okay, you just get an idea how this works. Then later on, you do your technique under the implementation of this. Not limitless sequential state search. Alright? For now, you get an idea first. Now, in order for you to insert a new item inside the list, okay, In this list, we assume, yeah, you cannot have any duplicate inside the list. Alright? You are going to use the function sequential search first to find whether the value is inside the list or not. If it's not inside the list, then you're going to insert it at the end of the list. And then you're going to increase the length of the list by 1. For this line, you can increase the value by 1. And then you're going to use the function sequential search inside the function insert add. Okay? So this is an example of, sorry, not insert add, insert, function insert. This one here, function insert. Okay? It returns nothing at the end of the function. We have void summary. Okay? Void scope resolution operator, operation insert. You need to pass the insert item. It has a constant value because you cannot change the value of the insert item. You insert it, you cannot change it. Okay? Not change the value that you want to put in. That's what you mean. Okay? Now, it says, now the precondition, the condition here, if the list is empty, easy lah. If the list is empty, then whereby the length is equivalent to 0, then you're going to add the list index by 1, then you're going to insert this item there. You buat tambah satu if the list is empty. But if the list has already reached its maximum size, then you cannot insert it anymore inside the list. Now, in the event that these two not already it's not fulfilled, then you go to the else part, the location. Okay, you go to the function sequential search, and then you pass the insert item. Then you go here. Now, the insert item you cari, does it exist inside the list or not? If found, we return the location, else we return -1. So, if you get the value that is not -1, sorry, if you get the value that is equivalent to -1, that means you cannot find the value inside the list, alright, then you're going to insert the item. Okay, at least these two, you tambah the line, and then you akan tambah this insert item ni. Okay, you pass dekat ni. One here. Else, if you found any value that is not -1, that is 0, 1, 2, 3, 4, you're going to say that the item is already inside the list. Okay? Now, if remove an item from a list, you go to use sequential search juga. Okay? The sequential search will return the index of the item to be deleted. Why? The return index because the implementation is dia akan give you the location. There, the location is the counter, not the value itself. Okay? So, you're going to use the function remove at. So when you remove something, then you're going to have to reduce the size by 1. Remove at. Okay, return type is void, parameter is integer. Okay, so this is remove. Okay, this remove return type is void, location, variable location. Now, if blank is 0, then there is nothing to be deleted lah. Else, the location equivalent to sequential search remove item. So, remove item ni, sequential search. If you found the item, okay, you return the location. Okay. So, if location is not -1, we need some index. Like a remove location, remove at location. So you're going to go to the function remove at. You cari kat sini, this one here, remove at. Okay. This one is remove here. This one is another function, which is remove at mutation. So you akan implement satu function yang akan remove the value inside the list. However, if it returns -1, that means you cannot find the item inside the list, then the item to be deleted is not inside the list. Okay? So, when you use function remove at, I will take remove at, okay? You have to decrease the list by 1 as well. Okay? So here you have to decrease the list size by 1. This is the time complexity of all the functions inside the UFL template. Some of you may be a little bit confused. Why? Simple. This slide here, this whole lecture note here, doesn't read each and every one of the implementation. So this one you have to go to the recommended textbook. Yeah, the implementation. Okay, is that clear?
Sir, what
Yes.
is return negative one?
Sorry, not clear. Can you speak louder, please?
What is return negative one?
Oh, why is it return -1? Okay, tengok sini -1 ni kan. Okay, tengok the outcome of sequential search. Sequential search is if you cannot find the item that you're looking for, you're going to return the value -1. Okay, so katakan bila dekat remove ni, okay, bila you dapat if the value -1, meaning you cannot find the value that you want to remove inside the list. So it goes to the second part here. If you return the index value, that means the value exists inside the list, therefore you can perform remove at.
Okay.
Okay? Alright, awesome. Alright, any question? Okay. If no question, that's all for today. Your assignment is going to be released this week, so please check your email here. It's a pair assignment. So what you can do now after this class, can you guys find your partner by yourself? Boleh ya?
Yes, sir.
Okay, can okay, preferably I want to do it by today lah. Lepas I habis kelas ni, I'm going to leave the session open. You guys find your own partners. Okay, kalau you dah ada, then you can terus log out. Yang tak ada partner tu, tolong cari sekarang. Okay, so everyone please open your video. Semua tolong buka video. Okay. Yang ada partner, ataupun agak-agak ada kawan, you can log off now. Yang tak ada partner, now is the time to find your partner before the question goes out. What I do not want is later on, tengah-tengah ke, dah nak hantar bagi cakap, I tak ada partner, I buat seorang. You buat seorang, I cut your mark 50%. So this is a pair assignment. You have to work together. Why you want to do it together? One want to test whether you can read another person's code or not. One of the objective of assignment and project. So when you work later on, you just don't do the work. You have to work together with your program. Okay? So yang ada partner, you can log off. Yang tak ada partner, tolong cari sekarang ya. Alright. Okay, that's all from me for today. Yeah? So I'm going to make some of you the leader of this session.